And I would like to ask you for this webinar to be recorded so that we have a register on this. If there is any problem with any of you, just let us know in the chat. I think I'm very, very glad to be here today in an event from industrial ecology community, which I've embraced so many years ago. And let me just say as an introduction to this session that the obvious. So buildings are a too much important infrastructure to be left alone from environmental concerns that I would say in the past were very much focused in industry or even in broader social constructs. So it is very clear that nowadays we strive for sustainability. So words like sustainable buildings, net zero buildings, circular buildings are very popular nowadays, and that is good. So we need to minimize their impact and if possible, even to transform them in sources of sustainability. But of course, this requires promoting sustainability by design, as our great friend John Ehrenfeld showed us back in time. And for buildings, this means that integration of the new tools, such as circularity indicators, LCA, needs to be included in building design and operation, which is to say in BIM. So having been working on this field for a while, we at IST took the opportunity of the great strategic vision of the EI grants, and we have been awarded a project together with a few companies, namely Tree Drivers, the project leader, Antonio is here representing Tree Drivers, and also our good friends at NTNU, namely Professor Helge Bratebro and Rolf Bonn. And this brought us here today. The project in which we are engaged is Eco Circular BIM, of which you will learn later on, and from which the idea of this session was born. So today we are in this session as a part of the Europe-Africa track of the Industrial Ecology Day. And indeed, the goal is to share research agendas of circular building to increase recovery, reuse, and recycling of construction materials. The session will cover different methodologies, including BIM, so building information modeling, and LCA integration, and circularity integration, and the analysis of circular material use in building stock will be discussed. So we will see bottom-up building stock models allowing to specialize in material use and resources, while simultaneously looking at future housing demand and renovation needs in cities. We have 6 great presentations from Maria Teresa Ferreira and colleagues in Portugal, Anita Naneva in Switzerland, Vanessa Tavares from Coimbra, Portugal, Muzak Barak from Israel, Technion, Omar Alomar from Newcastle University in England, Peter Hertogs and Rudy Stuffs from the National University of Singapore. And I would immediately invite Maria Teresa Ferreira from Técnico to provide us some details on the project that indeed we are conducting and brought us here as the idea for nucleating this session. Welcome to all of you. The word is yours, Teresa.
Thank you very much, Professor. Good morning, everyone. I will share my screen. Is it working okay?
It is perfect.
First of all, I would like to congratulate the organization of the Industrial Ecology Day and say thank you for selecting us to be here today presenting Integrating Levels Framework and BIM for Buildings Sustainability Assessment. This presentation is divided in 4 main areas: introduction, integration of levels framework within a BIM environment, 2 case studies, and our main contributions as a conclusion. Introduction: circular economy, building sustainability, European normative system levels. This is a diagram that shows the circular economy life cycle circle for building sustainability. Circular economy is a systematic approach to economic development designed to benefit business, society, and environment In contrast to make waste linear models, circular economy is regenerating by design and aims to gradually decouple growth from the consumption of finite resources, looking for energy efficient, renewable energy, incorporated materials, efficient use stage. Levels framework is an European normative system for the building sector. At the moment, construction industry is responsible for half of the extracted materials, half of the total energy consumption, 1/3 of the waste generation, 1/3 of the water consumption. This is based on the European Commission data. Levels is an holistic approach, brings buildings into the circular economy and makes life cycle performance understandable to the involved parties. Policymakers and public authorities, building professionals, investors. It's an European Union-wide assessment and reporting framework for sustainability. It covers the whole life cycle approach, measurement from design to the end of life. It has several core indicators tested by the building sector for residential and office buildings. It works both for renovation and new construction. It has 6 macro objectives listed: greenhouse gas emission along building life cycle, resource efficient and circular material life cycle, efficient use of water resources, health and comfortable spaces, adaptation and resilience to climate change, optimize life cycle cost and value. From all the core indicators, we selected the ones that can be read winning a BIM environment from the construction elements. The core indicators selected are the ones in green. For example, use stage energy performance, life cycle global warming potential, bill of quantities, materials and lifespan, construction and demolition waste and materials, design for the construction, reuse and recycle, life cycle costs. It's a life cycle approach covering all the project stages from level 1, conceptual design, until level 3 as building use, facility management and operation. This presentation is focused on level 2, detailed design and construction, and how we can influence the construction industry. To achieve level 2, some definition needs to be placed. Project plan needs to be defined, and if it's a renovation, a baseline survey needs to be done. Some information is required, for example, location and climate, building typology and age, how the building will be used, building model and its characteristics. From our research, we found there's a lack of interoperability between European Union standards and supply chain tools. So our proposal is an integration of levels framework winning a BIM environment. BIM is also a full life cycle approach covering all stages of the project, keeping the data in one single model or several models connected to each other, making from programming to conceptual design, detailed design, analysis, documentation, fabrication, construction, facility management, renovation, and the possibility of reuse, and especially for the information to be kept and consulted by all parts involved. We'll use BIM as a common ground. But to introduce levels into BIM, we needed to define a product data template with the macro objectives that we selected, the indicators that will be converted into parameters that will be read winning a BIM environment, the values that will be given by our database, environmental product declarations, and we will be filled for construction elements or BIM objects and the units of analysis. We will also extract a BIM of quantities, materials, and lifespan, which is already very common to be used in the construction industry, construction and demolition waste and materials, design for the construction, reuse and recycle, and the life cycle costs. We studied 2 case studies, one for refurbishment and another one for new construction. This is an example of an archetype, typical residential building in Portugal with the information field. The second one is a new construction from Ateliê dos Remédios. It's a new construction, 4-bedroom house with 2 living rooms, kitchen and exterior garden. We made a survey of the BIM objects, mainly doors, windows, sanitary fixtures, and kitchen, listed the materials, the thickness, and also coded with a unique class. From those, we found that the most important and with a bigger influence or bigger impact are doors and windows. We also did a survey of the construction elements, walls, roof, floors, and structural elements. The materials are listed, the thickness, and the codification with unique class. These are the proposed materials by the architect. We will make an analysis using our product data template and possibly propose some options for materials to achieve better results. In conclusion, our main contributions in circular eco-BIM projects exploit the potential of BIM to improve the choices of material and the assembly of constructive elements so that the full life cycle of the building, the materials can be reclaimed, reused, and recycled, and the environmental impacts are reduced. Through a BIM LCA integration in our product data templates that will be filled with information from a database based on environmental product declarations. This information provided by material will be read using BIM software. We are using Autodesk Revit, and our plugin will run. It will be one plugin with 5 main functionalities: streamline LCA, carbon footprint, cost, and circularity, all of them converted into levels. Levels already has all of these 4 analyses winning in it, but we wanted to give the final user the possibility to extract either levels and one simpler analyze at once. Thank you very much for your time. And for more information, feel free to contact me or my colleague, Joanna.
Thank you very much, Teresa, for a very interesting presentation and for keeping the time, which is, of course, also very important. Thank you. So I believe that Anita Naneva is not here. So if not, I would like to advance and invite Vanessa Tavares from the University of Coimbra to make a presentation right now. And then, of course, if Anita shows up later on, we will have her presentation as the last presentation today. So, Vanessa, are you able to?
Yes.
Thank you. Please, the word is yours.
Thank you all. My name is Vanessa Tavares. I'm here presenting a case study, a life cycle assessment of a prefabricated modular house, but using a BIM LCA approach. I will do the introduction, present materials and methods, results and discussion, some conclusions, and future work. We all know that buildings and construction sector are responsible for a large share of impacts, materials and energy mainly. Prefab buildings use less materials. They are based in prefab components or modules that are done in plant and then after assembly. They have different degrees, but there are some trade-offs that we need to unveil. Life cycle assessment is being increasingly used, but it's time-consuming and data intensive. It's challenging to be applied during the design process. So new streamlined approaches need to be further developed. And BIM is one of these methodologies that can enable that. Through a BIM LCA integration.
Vanessa, yes. sorry to interrupt you, but you are not sharing the PowerPoint.
I'm not? So sorry.
You are not.
Okay.
Oh, no. I should have interrupted you sooner.
Sorry, I'm not sharing, so I'm sharing what?
Not sharing anything.
Okay, 2 screens, that's worse. Let me see.
Now you're sharing something. You're sharing
the PowerPoint.
Yes.
Now we are okay?
Yes.
Okay.
Yes,
okay.
Perfect.
It was only text. You can see now, so you didn't miss anything, okay? I'm here presenting a graphic previously done by McLeamy. Everyone knows this graphic. And we know that the curve of to impact cost and functionality decreases with time, and the effort of any design change increases. And the traditional design process is somewhere in between. And we want to bring the design choices to an early stage where we can impact costs, efforts, and here I'm introducing also impacts. The LCA assessment, when it's done even later on. So we want to bring this LCA assessment to an earlier stage. And we can do it with a BIM LCA approach. To develop a BIM LCA approach, we can account for the house impacts, analyze the influence of climate, HVAC systems, transport, insulation levels, and understand the trade-offs between embodied and operational stages of all the alternatives. Here I'm presenting a single case study of a prefab detached house, 1 story, 1 bedroom, 56 square meters, and built in 2 phases because it's modular. First models are produced in plant and then they are transported and assembled on site. It was a real house that was done. Here we have a picture of the house after completed. Floor plan, 3D model, the energy model, and 3D views. Materials are extracted, transport to prefab plant. It's off-site production, then assemble, and then the use phase. Here, all the alternatives that we have assessed. But in this presentation, we are presenting just global warming and non-renewable energy. We have 42 alternatives, combining the installation levels, the HVAC systems, and 7 final locations. And here we have the inventory of embodied phase. The materials were extracted directly from the BIM model. And the operation phase, the energy demand was assessed through the Revit model and Energy Plus linked to it. We can have some variation due to different HVAC systems. Here presented, we have the energy demand for Paris, Aveiro, Lisboa, Faro, Casablanca, Rio de Janeiro, and Luanda, that were the markets for this specific house. And we can see that impacts don't linearly translate the energy demand because the electricity mix of France is a bit different. And here the contribution analysis when we can see the impact of use phase, different in each city. Here we have the use phase in detail with the HVAC system and our appliance with the greater impacts, and the impact of materials with different insulation levels per element. We can see how increasing the insulation level could impact impacts, and we can see that it can have a positive impact in Paris, Aveiro, Lisbon, and Faro, but not so positive in warmer cities. In conclusion, we can see embodied and operation phases. We can see that the electricity mix influence results, and we should adapt the prefab house to the final location, adapting the insulation level. We should choose materials with low impacts, and the same with processes. And in a future warmer planet, the cooling needs can increase and will increase, and maybe prefab houses can have a better performance in that. Now we can use the BIM LCA approach as an interactive process, and it can more easily balance embodied and operational. And it could be, if introduced in the design process, it could be done by non-experts, non-LCA experts during design stage. And has an advice, we would advise that both databases of costs and impact should be external to the software and linked to the software, so we can update it and change it from place to place and from year to year. As future work, not directly related with this case study, we are developing a tool that can link Excel with Revit through Dynamo, and we can use some of results from CIMA Pro and Energy Plus in that plugin, that we have to have the parameters defined that will be the input from the BIM model. Then they will be introduced in Dynamo, and results from Dynamo can feed back the process. Here we have the model with the geometry, different materials, and energy performances. We should build up the library with different compositions of external walls, internal walls, roof, floors in different materials. This library is recognized in Dynamo, and we should program the algorithm so we can have differences in geometry and in windows, window-to-wall ratio, in materials that were previously defined, and do the energy performance in different places with the different results. And then extract that data to feed back all the model. But this is a work in progress. Thank you. I don't know about my time.
It is perfect, Vanessa. Thank you so much. And thank you for bringing the slides to all of us.
Sorry, I should have. Sorry.
Wonderful. So thank you very much. So we'll now go to Israel, Technion, Israel Institute of Technology, and Musab Maraka will present us his paper on BIM Material Passport to support building deconstruction in a circular economy. Please, Musab Maraka.
Hi, good afternoon, everybody. My name is Musab Maraka. I'm a PhD student at Technion, Israel Institute of Technology. So I will give a presentation about BIM Material Passport to support building deconstruction and a circular economy. First of all, I will give an introduction about the BIM. So the glossary of the BIM handbook defines BIM as a verb or adjective phrase to describe tools, process, and technologies that are facilitated by digital machine readable documentation about the building, its performance, its planning, its construction, and later its operation. The material passport is a qualitative and quantitative documentation of materials composition of a building, displaying embodied materials in building, as well as showing their recycling potential and environmental impact, which in turn gives them value for recycling and reuse. So it's an important instrument for the enhancement of circular economy in the building industry in order to minimize the carbon footprint. The main results obtained from the material passport are the mass distribution within the building, the share of recyclable and reusable materials, and the total amount of global warming potential, acidification potential, and the primary energy intensity originating from the incorporated materials. In our study, we selected that to develop a material passport for Microsoft project. The building is located in Herzliya near Tel Aviv. This is the second largest project for Microsoft out of the United States and its LEED Gold certified projects. The project consists of 5 underground floors and 8 floors on top of the ground. Its area around 50,000 meters square, and it's implemented like the main structural elements used in the building is concrete with curtain walls from aluminum and glass. Now, they used several innovations during the design and construction for this project. They used the BIM in the big room, which means that designers from multi-disciplines were set in an offices near the project and works in a central model in designing the project and optimizing its performance from environmental perspective. Also, they used the lean implementations like last planner system, which is a production planning and control methods, value stream mapping, 5S, all the lean techniques in terms of managing the project. Now, we started developing the material passport for the building. So in our methodology, it's divided into 2 phases. The first one is about working on the BIM model. In the BIM model, we defined like the different families, which for example here, the concrete materials, the curtain walls, the flooring, also there is the blocks, for example. Now in each family, there is several types. For example, like the concrete, there is P200 until P500 in the curtain walls. There is several types of glass, aluminum, curtain walls for balcony, for lifts. We extracted all the quantities from the BIM model. For example, the curtain walls area around 27,000 meters square, which is high potential recyclable materials because all of it's from steel and aluminum. We took all these quantities and use it as an input for the GABI software. Now we are in this stage of the research. This stage is like, there is a lot of challenges in this stage because we are collecting data from the construction site. Now for each material used in the construction project, we need like the product and the commercial name. We need the composition materials, the manufacturer suppliers in order to make an assessment for the transportation from the factory to the construction site. Also, we need the use period and time, because for example, if the project design period to be 100 years, but we need to replace the tiles after 30 years or 40 years, then the quantities will be doubled or tripled, depends on the period time for each material. We need the technical data, and if there is some recommendations or restrictions in some material. Also, we need to know like the end of life for each material, if it's reusable, recyclable, or it need to be demolished, because we need to give a weights for each material depending on its reusability and recyclability from 1 to 5. The other thing also, we are collecting all the invoices for the materials delivered to the construction site in order to estimate the amount of waste, because the amount of waste equal the actual delivered materials minus the actual build. The actual build are the same materials from the BIM model, because the BIM model here is the as built. So it represents the reality and it represents the actual quantities that it used in the construction site. So by subtracting what delivered to the site minus what actually implemented, then we know the amount of wasted material, which in turn go to the landfill locations. Now in this GABI software, now we are in this phase, it's not ready yet. We are making on evaluating all these input parameters on the GABI. The main output will be the global warming potential, which will be represented by the 3 parameters: greenhouse gases, acidification potential, and the primary energy material, which will be represent the material passport for the building. Now, this slide show us the scorecard for Microsoft Building. How I mentioned, the building got the certificate of leadership in energy and environmental design in the gold degree. This show us the points it's got it in different categories: in the sustainable sites, the water efficiency, energy and atmosphere, material resources, innovation. If we look here in the innovation, we can see that the building achieved 5 out of 6 points, because the building achieved like innovation technologies during the design, and also in the construction phase, they're using like innovation in construction management approaches like the lean philosophy in order to reduce the amount of waste in products and waste in each process and its associated operations. And thanks very much for listening for the presentation. And for more information, you can contact me on these emails or on this phone number.
Thank you so much, Musab. Very interesting. And so now we go from Israel to the UK. So to Omar Alomer et al. From Newcastle University, which will present to us a paper on the integration of BIM and MFA to assess the environmental impacts of building material selection at design stage. Please, Omar.
Yeah, hi everyone, and thank you so much for the chance and for being here. My name is Omar Al-Umair. I'm a PhD student at Newcastle University, and my project focuses on integration, BIM and MFA to assess the environmental impact of building material selection at the design stage. And my research supervised by Dr. John Kamara and Dr. Oliver Heydrich. First of all, let's do some outlining of my presentation. Today, I will go through about my aim of this presentation. We speak about the background and challenges of the issue of the selection of materials. Then I will speak about the integration process stages, then show some results, recap, and the next step. The aim of my presentation today is show my current work, which I'm working now on building information modeling as a design technology or software, which I'm using Revit, and LCA software, which I'm using Umberto LCA Plus. My aim or my project aim is to develop a platform that I can integrate BIM and material flow analysis MFA together to help the designers and architects assess the environmental materials at the design stage before the later stage. And I'm still in progress. I've got 2 years left for my PhD to complete this platform. And the main aim of this presentation today to connect with other researchers, academia, and professionals, and to learn from you. Background. Buildings become one of the major impact to the environment, which more than 40% of the global energy use and 18% of the greenhouse gases comes from the buildings, which are reported from the IPCC 2013. In the UK, in 2015, there is a report shows that 30 to 70% of CO2 emission comes from buildings. That means buildings are one of the major impact to the environment. Some studies shows that as well. Building materials have a significant impact to the buildings, which lead us to think about the decision-making of selection materials as also has a great impact to the environment. When we say about the decision-making of selection materials, always think about the architects and designers at the design stage, which the designers and artists are in the challenge to select the materials, they are left alone at the design stage to select these materials. As we found, some studies shows that there is no tool or data help designers, architects to specify the environmental materials. Also, we did some small scale of interviews with some UK designers, and we asked them about the technique or tools that can help designers to select the materials or building materials at the design stage. And they said they are left alone in selecting the materials, which the materials are based on their knowledge experience. Here we came up with the integration of a platform that can help designers and architects to specify environmental materials at the design stage, which we believe that if we control the materials or control the impact at the design stage will be much better than control the impact of environment and later stage of the building or the building project. The integration has 4 different stages, which start with the BIM stage, as we use Revit as a BIM software. Then followed by the exchange stage, which I'm using IFC, Industrial Foundation Classes, to exchange data from BIM, as BIM is closed data, to Microsoft Office, which will be linked directly to the MFA LCA software, which I'm using Umberto software. As we can see here, after achieving the three stages, we can say this is materials that we have specified or chosen can be environmental or not. If not, we can return to the BIM stage and modify these materials. If it's okay, we can just move forward to develop the platform. That platform can help us to integrate BIM and LCA or MFA together, and we can do the process again faster than we explained. This is our result as the design was constructed for this project as I'm still not having the case study to test the integration process or the platform. And here's some, like, I use some generic materials and the software was BIM. And here's some results of the integration. As I can see, as we can see all, there is some, like, different materials has great impact to the environment. As I used IPCC method, climate change, GWB 20A and 100A. As we see, cements is the most impact material to the environment. Here's summary back. Building materials has a great impact to the environment. And there is no tool or data that support architects and designers to specify the environmental building materials at the design stage. Architects and designers are alone to choose the project or the building materials without any help or support. The integration of building information modeling and material flow analysis will help selecting building materials at the design stage, and selecting building materials at design stage can control the impact of materials on the environment before being in the late stage of the project. The next step, I have 2 years to achieve the platform, and I'm looking to connect with others in the same interest. And material selection is still the gap on the environmental impact or the gap in the building industry. Design can help reduce much environmental impact. And I'm still needed to work in the LCA and BIM as well. I'm still looking for the case study. At the end, thank you so much for your attention, and I would be very happy to answer your question. And for contact and collaboration, please scan the QR code. I would be happy to contact you and have collaboration. Thank you so much.
Thank you very much, Omar, for another very nice presentation, and indeed fulfilling the great objective of this session, which is to have people doing related work and wishing to share knowledge with each other. Well, and now we make a big travel to Singapore. So we have Dr. Peter Hertogs from Singapore ETH Center and Professor Rudy Stout from the National University of Singapore, presenting us a paper on estimating material recovery yields by modeling material configurations in BIM, the circular economy potential model. Please, the floor is yours.
Yes, I lost my controls for a second and I couldn't figure out how to unmute myself. So thank you for this introduction. Thank you for having us. I'm Dr. Peter Hertogs from the Singapore ETH Center, that is ETH Zurich's satellite in Singapore. I'll be presenting with Professor Rudy Stufs from the National University of Singapore. We are both investigators in a project called Circular Future Cities. I see that our other principal investigator, Steffi Helweg, is also in the audience. And the Circular Future Cities project starts with a constatation that while we're all here gathering and studying building circularity, it's important to remember that the circular economy itself exists at a city scale, or at least at a scale beyond the building. And so this economy depends on systems at a scale that is larger than the building, and it depends on inputs and outputs from the building to this economic system. And so the Circular Future Cities project aims to digitally support circular economies in construction at the city scale and brings together several investigators working on work packages that interlink from this kind of city system perspective. So at a city level, we're talking about systems analysis in terms of flows and cycles and diagnosis, but also then, of course, mapping environmental hotspots in terms of resources, for example, or material stocks. At the level of the building, we're talking about how can we model construction material recovery yields in more advanced ways, and that's what we're talking about today. But there's more in terms of can we improve the upstream design of materials and material flows, so the flows that go into the building. And what do we do with the flows that go out of a building in terms of the information management materials? Passports has been mentioned, or how do we entice people to actually store all this information that kind of only has value in the future? And one work package looks into using blockchain to stimulate such markets. And of course, we have a work package looking at the synthesis and engaging with the stakeholder network. And that's also why one of the parts we're here. Now, our main idea is to develop a circular economy potential model. And this model will model material recovery yields based on properties of material configurations. And so what I mean with that is that the configurations of your building materials matter. So a building is more than a collection of materials by weight, let's say. The way you actually connect all these materials, the connection types you use, actually has an impact on how many materials you get back, in which state you get them back, and things like that. And that is what we want to model. And so material configuration, in a sense, is simply design, and that affects recovery in many ways. It affects disassembly, it affects damage of components, it affects contamination, service life, risk, the adaptability of the building itself, and aspects like that. And so because we're looking into quite detailed modeling, our scope focuses on new construction in a BIM environment, because we're literally looking to modeling the nuts and bolts. I think the main message is that we're exploring a shift in paradigm, and we're exploring a shift from urban mining, which is often used, which is a paradigm that actually reflects an uncertain kind of once-off discovery of precious materials. There's, you know, copper somewhere, or gold, or rebar, and we need to find it somehow by screening lots of unknowns. But actually, the paradigm that we want to go to or explore is a paradigm of urban harvesting, you could call it, rather than mining. And that's a paradigm of certain, plannable, and cyclical recovery of materials. Because if we're all here designing buildings in advanced ways to make them more circular, well, then we'll know a lot more about when we get materials back and when we can reuse materials, and how that influences the circular economy as a system that lives beyond the building. So today we want to present our research agenda for this work package, and it's based on 4 research questions. The first question explores the modeling. How do you model with configurations, and how does that impact life cycle assessment? The second question looks into how do all these goals combine, because there's many kind of sub goals in circularity, and if you do one thing, does that affect another thing? Does that affect yield of materials? And we're talking about yield similar to agriculture, in a sense that, you know, you sow wheat and you get a certain yield of wheat, and similarly, you know, we'll be sowing concrete and getting concrete back, but the amount you get back is the kind of model. The third question looks into the potential impact, and how can you actually start planning with such with your yields of materials in space and in time. And then fourthly, what's the feasibility of this new paradigm? Because of course, we're looking into something quite advanced in the sense of modeling nuts and bolts. How far is this idea away from current practice in BIM and information management? So the first question is, how do we model yields using material configurations? And between brackets, how does this affect LCA? Because the LCA part is actually in Steffi Helwig's work package. But of course, there is an impact. And by configurations, what we mean is how materials are combined and connected. So on the left, you see some work in progress, a work in progress screenshot of modeling how different alternative types of gypsum board and steel frame walls are assembled, and how they could be disassembled. And so those connections can be modeled as graphs, so that a metric of the graph can then express, for example, the disassembly potential. And so the properties of how the materials are connected, and which materials are connected, and what connection types are used, will affect how much material you get back out of a building. And so it's not as simple as a tonnage of waste. It does affect, so the connection affects the recovery rate, and that that impacts LCA, that impacts policies you might want to do, etc. And of course, as I mentioned, it's detailed, so we start from BIM and construction. Now, the second question is, how do we model and evaluate the implications of material configurations on different goals? Like I mentioned in the run-up to this, building circularity encompasses many goals. And so our circular economy potential model aims to capture this plurality of goals, because it's not only recovering materials, you're also, it's not only reuse of material, it's also reuse of components, reuse of systems, reuse of buildings in their entirety. And so what we will need is a suite of indicators for different goals. And so we plan to combine existing, adapted, and new models and metrics. In the image, you see a floor plan, and you see values below here. Giving you floor plan values for the adaptability and generality of this floor plan. That's a model I developed a couple of years ago. And those properties are determined by your configuration of materials. But your maintainability of services, for example, is also determined by your configurations of materials, as is the circularity of the components, as is the disassembly and potential of walls. But of course, if you work on the configuration and you make your for example, walls more easy to disassemble, it could also be that you make your building easier to maintain, easier to adapt, and that the building, has a longer lifespan, which is good, but it does imply that your yield will be further back in time. So if we're talking about planning yields, that's an important thing to understand and to model. And of course, because we're combining all the models, we need to also think about how to inform the user to tell them which goals are met, how they interact, and things like that. I'll give the word to Rudy now.
Thank you, Peter. So the third research question is, how do different circular economy goals affect recovery yields, and how does this play out in space and time? And Peter already pointed out to it. I mean, the first point is that we cannot just look at simply recovering these materials or their components. This is heavily linked to building reuse potential, maintainability, adaptability. And so all these things play a role, and they affect time. So of course, it's not just about which materials are available in a certain radius or distance, but also when can they be harvested in time, and will they be harvested as individual materials, or will the building be reused? So understanding these yields is of course required to plan resource needs, and this is how we can move towards the true circular economy. We have to adapt the needs basically to what becomes available. So we need to know what becomes available when we are planning our buildings. Next. And then our fourth research question is looking at present BIM standards and practices. What types of building information are needed for a circular economy potential model? So what's the feasibility of an urban harvesting paradigm? If we look at practices, and ideally at best practices of BIM, and we look at the required info, what's the gap between the two? What extra information has to be available in the model, and how can we intend, have these practices adopt to collect this information? And this, of course, depends very much on the information management, which will be studied in the material passport team of the Circular Future Cities. And it also depends on encouraging information capture, for which we are exploring the use of blockchain for exploitation of digital building assets, again, in a slightly different theme of the project. Next. So if these four research questions, of course, aren't independent questions, they are related, and they are specifically related to the Circular Future Cities project as a whole. We've got the first research question and the second research question are very much interacting with each other. First research question also connects to the theme of system analysis and diagnosis, where we look at the LCA diagnosis and mapping. And the results from the research question 2 lead to research question 3, which is in itself, as I said, already connected to mapping of building material stocks. And 1 and 2 together will feed into research question 4, relating to digital information ecosystems and blockchain-based digital building assets. And so all the work comes together towards a holistic view of the circular economy potential of buildings in a urban setting. Next. So we expect that our research agenda touches upon research gaps that are encountered by many. We're aiming to explore a future truly circular paradigm. Obviously, this implies a very methodological and model-driven study. We're looking to model connections in detail that influence BIM and LCA, setting requirements for BIM and influencing the results of a life cycle assessment. And obviously, building our knowledge is a collaborative endeavor. So we're happy to talk and exchange thoughts with all of you and beyond. Next. So in conclusion, by modeling how material configurations influence material recovery rates, the circular economy potential model will integrate both BIM and LCA for circular construction. Next. And we thank you for your attention, and we'll be available later for questions and discussions. Thank you.
Thank you so much for both of you. And indeed, thank you very much for recalling how important it is a systems perspective and the way we configure material use. And I would also say eventually how we adopt design for flexibility and certainly recognizing the relevance of space and time. I think these are all very, very nice issues for the discussion that follows, because I believe that Anita is still not here. So then it is really time for discussion with the speakers. And this will be coordinated by my dear friend, Professor Helge Bratebro, to whom I pass the word immediately. Thank you all the authors, looking forward to the discussion. Thank you very much, Helge. The floor is yours.
Thank you very much, Paolo. And thank you all the presenters. I knew when I just saw the abstracts that we will have a package of quite interesting presentations. And of course, the contents of your slides just demonstrate that there is lots of information behind here that we need to examine more in detail. Also, it tells about the variability in how you approach your different research. So please share your slides. And also it would be nice if you could point to some key papers, but that could be done, I guess, later on. With respect to having a discussion now, since each of the presentations were rather different, Verena, could you please bring forward the slide with some overall questions for discussion?
Yes.
We have a little less than half an hour, and I guess we should certainly save at least 10 minutes for the audience to ask some questions. So the next slide shows some question at the more, let's say, overarching level. When I read your abstracts and when I listen to your presentations, it strikes me that the circular economy or the circularity challenge of building systems could be seen upon at different levels. Of course, we are focusing on the materials use, and some of you have focused on, let's say, the reuse or recyclability of materials at the end of life, while other fully focus on the life cycle resource efficiency, which, however, there is a difference here, because if you focus on the life cycle resource efficiency, that would be the consumption and the materials efficiency during the whole lifespan of the building, which is a slightly different, let's say, target than the reuse and recyclability of materials during deconstruction. But then, of course, also the impact focus is on a different, let's say, scale or scope, where you could focus more directly on some few environmental impacts and costs, or wider on sustainability. And of course, I would assume that we all agree that the impact is the end purpose here. Recyclability and circularity is only the means to get there. How do you see this? And given your answer to this, what do you think are the two top priority, is it building circularity features or characteristics, opportunities that we would try to influence the most by design? And how should we go about to achieve that in the design process? So maybe if we start with, you could of course take the word by just specifying your name in the chat, but let's start with Peter. How do you see this, Peter? Because your focus was rather on the systemic level, I guess, and therefore also you are thinking holistically on this.
Yeah, it's an interesting question. I'm afraid that my answer might not be too satisfactory in the sense that my overall research interest is design evaluation, and in that sense, I understand that everybody always has other priorities and other end goals. So, let's say in a larger sense, I don't think there's one kind of goal, or that. So I can't, that part of it, that philosophical part, let's say, I can't really answer. Nevertheless, for me personally, I think the importance is in using resources wisely, and I think that points towards resource efficiency. Nevertheless, methodologically, I think that also means modeling it well. That's, of course, the point of the presentation we did. But in that sense, understanding the relationships well and understanding how the systems work, or how design and the actual efficiency relate, and how that can be further integrated, is in a way, it's not an end purpose clearly, but sometimes, the means and the end blur. So that would be my answer. That isn't to the core to your question, unfortunately, but that's my mind, my worldview. So
yeah, okay, but that's a good reflection that I understand. But in your presentation and in your team, you focus on the city scale. So of course, when doing that modeling exercise, you are trying to represent mathematically a very complex system. And how do you then relate to the challenge that you will have to invest tons of work in order to build the inventory, in order to know the data, and still you would like to come to certain, let's say, clear recommendations as soon as possible without having invested all that tons of work on all, let's say, different levels and fractions or subsystems. How do you relate to that?
I think in a way, the importance of coming together with, because our project, brings together many investigators, many perspectives, domains, but also this meeting does the same. In that sense, understanding each other's end purposes is, for me, and mapping those is very important, because that is also a lot of work. Just simply the act of understanding each other is a lot of work, but it's worth it, because that's why we're here. So in that sense, I think, and the more we understand each other in terms of, the jargon we use or the goals we have, or, whether, if you understand better what people's goals are, whether it's the larger end goal or the sub goal, that to me is a big step forward. And that by itself is a big thing you need to take into account. I used to work in the Buildings as Material Banks project. And there too, you bring so many people together. And we even had a work package working on a common language for all the all the domains that come together. So in that sense, I think it's all a lot of work, but it's all good work in that sense.
Yes, thanks. And Maria Teresa, you also in your group examine a quite wide range of circularity and let's say categories of levels. So how do you see the top, given your answer reflection to this question, how do you see what are the top 2 priority circularity features for buildings that you think would be the important thing to influence by design? Maybe it's too early. Maybe it's too early since you only have a limited number of lesser data or results. But still, what do you think about it?
I think I have 2 perspectives. One, if it's a new building, another one, if it's a refurbishment. If it's a refurbishment, we should do an exhaustive analysis what the materials and construction elements and systems that are already and can be reused or reapplied on the new design. And if it's a new construction, we also have to see if we can apply recycled elements and study the data from all the materials, construction elements and system, and calculate how can we achieve better results.
And Vanessa, what do you think? I mean, your work is on a building and you had the opportunity to implement BIM data, for instance, quite detailed on the HVAC systems. But in the end, then your results points to that these systems doesn't really have a large contribution. It is the concrete and it's the glass walls that actually mainly give the contribution to the life cycle impacts. So given that, stretching towards a quite sophisticated model, but then in the end, the focus, the results point to that circularity features would mainly target some few materials of a buildings and some few components. And maybe we knew that already.
Maybe I should know that already. But the point was to have a case study that could show how could we integrate BIM LCA approach during design stage, and how can we bring these high level issues to a down level practice. In fact, I'm an architect as a background. I've worked as an architect in that project, but I had no idea of the impacts of my decisions could have in the future. So we need to have this tool that is streamlined and could be introduced in design stage. So I think every designers want to do the best. Yeah. And they don't want to have high impacts, but we need more information in advance, and bring that to design stage could impact the life and even circularity of the buildings. But we should design for the construction, and we should design having all this knowledge, and we don't have. And the point was that maybe the conclusions were typical, or I should have seen them before. But the point is to bring information to design stage where we can, in fact, have influence in impacts, not only now, but in 50 years.
Yeah, and I agree. But do you think that, given, for instance, the case study you worked on, yes, Vanessa,
yes,
do you think that it would be possible to have, let's say, the inventory and the data at the required level of, let's say, uncertainty at the early design stage, if you didn't have that building documented already at the detail level from BIM?
I think we could have libraries that had typical compositions, because we use, I don't know, 10 types of walls at most. Yeah. Most of designers use the same solutions in 10 types of solutions for roofs or for walls or for floors. And that solutions could be detailed, even for a square meter, impacts for a square meter or for a unit of window, or I don't know. We don't have to have that match of information. We could have just our library detailed, and with costs also. That's why I suggested that the BIM model should be linked to an external database. So we could update it and have all results updated in an early basis. And that could be a national effort, maybe for each country, or even a market effort, I don't know. And if you have impacts for square meter, then you could calculate in a early stage the impacts of the buildings. Then the simulation of the energy needs now are much easier because you have energy models linked to the BIM model. It's not that hard to have the results of the energy needs and the part of at the end of life. It's
thanks a lot, Vanessa. And that points, of course, to what you said directly. We need some kind of, let's say, database for statistical analysis in order to harvest some Shablon values or whatever to make use of. And Musab, you say, I really like your suggestion and your way of phrasing it, putting BIM into the big room, so at an early stage. And that means that, of course, you also are working on a sophisticated model towards passport, material passports. And to what extent will a material passport for a given building, the building you are analyzing, depend on the building itself or mainly by the materials? So to what extent is data, let's say, the main lessons learned that we can see from when you have a materials passport, to what extent do you think that will be transferable from one building to another?
Yeah, so like I want to talk about the BIM in the big room, which is like a product development technique in which designers of different like subsystems are brought together to promote communication and collaboration, like to optimize the design. So for example, if we are making in the design phase, the BIM in the big room started. So if we need to construct the partitions wall for the project, so we can optimize like the block type. Shall we use, for example, concrete block, gypsum block, autoclaved aerated concrete block? So in this phase, we can make the life cycle assessment for each one. For example, if we use the concrete block, so then the recyclability for these materials is not a lot because it's at the end concrete. So we'll use it, for example, as a filling materials. But if we use gypsum blocks, on the other hand, the gypsum block is recyclable because they will grind it and they will use it another time in making like gypsum block, for example, the wasted materials, or even at the end of the building's life cycle. So the BIM in the big room gives the ability for the all disciplines in order to optimize the materials used in the project during the design and to benefit from the BIM model further through the operation and at the demolition stage.
Yeah, thanks. So, Diana, could you please forward to the second question? When I was reading your abstracts, I was thinking, okay, so this is the landscape that we see here, or some of the landscape that we foresee in this research. And to succeed in influencing then towards more circular and with an impact building systems, I guess we need three things. We need new methods, that is integrating BIM with LCA. We need empirical data and proof of concept studies in order to get evidence for what might be generic principles or principles that with certain level of transferability on what to do. And we need, of course, to implement that knowledge and those methods in design and in early stage planning for construction and renovation projects. Where do you think the shoe is pressing the most today, and how can we ensure that new methods actually make a difference? Start with you, Omar. According to your research, where do you think actually the shoe is pressing the most? Is it on lack of methods, or is it we have methods, but we lack data and good data and proof of concept studies in order to implement? Or do we know enough, but we are not structuring that, tailor-making it for the early stage planning?
For the interrogation, I think the most difficult or the lack of data, it's kind of the major issue in the method. As when we want to interrogate BIM and LCA, it's kind of difficult because if BIM is a closed data, that we need to exchange the data from BIM and LCA, and there is no tool except like IFC help us to exchange these data. Also, when we want to link the data or transfer the data from the LCA or from BIM to the LCA, we cannot like we don't have like any tool or tool to help us to transfer the data from BIM to the LCA. That's why we need to do it like manually, or the, like I said, old version that we use Excel. That's why let us to consider about integrated or developed platform that help us to integrate BIM and LCA.
Yeah. Okay, so I guess we partly covered this already, but anyone else of the presenters would like to add some thoughts here before we go to the questions from audience? No? Okay, we have some questions from the audience. There is a question from Oliver Heidrich. Of course, I wholeheartedly agree, but working with architects and clients could be a case of beauty over function. That is, material passport is a great idea, but will people actually use it? Omar, what do you think? No, sorry, Musab, what do you think? Will architects actually use it? Or are they still, let's say, kind of bound within their tradition of working more with respect to intuition?
Like, I think the use of the material passports like is not so popular, and it's started recently. But I think, yeah, the client will be motivated to implement like the passport if the client is interested, for example, in implementing like the sustainability issues. Like, for example, when you are a client and you need to build a green buildings, for example, so your goal or the value for you as a client is to make sustainable buildings. So when we introduce the idea for the material passport, especially for the green buildings, how I mentioned in our case study is a lead project. So it will be motivated for the client to get like to know the material passport for its building, and to know like the embodied greenhouse gases and all these things in his building's components.
Yeah, but I would just personally like to add a reflection here, because I think this is a very important question. As researchers, we are super clever in building new models, but what about the use of those models? And I think we have a big responsibility on our shoulders in developing methods and new models in such a way that actually we can demonstrate their usefulness to those who are using them. So I'm still hopeful on the approach of material passports. A question from Laila van Ellen. Thank you for all your presentations. I have a question to all the speakers. We all agree that we need databases, models, and tools. However, who do you think should host, moderate all this data? And then there is a second question from Rudi. We could imagine, or that's a comment, we could imagine a market for such data, like a stock market. What do you think on this? I don't have any, let's say, kind of experience on some joint market initiatives or initiatives across, let's say, clients, companies working in the area, for instance, in the construction sector. Mostly in Norway, they tend to protect their own data. What do you think? Any experience on this? And how realistic is a marketplace for such data? Would you like to add some comments to that, Rudi?
Sure. So, I mean, I think that the big problem, of course, is that the data has to be generated at the time that the building is conceived, built, but that the yield is only so many years later. So who is going to sit on this data for so long? That is really the big question. And I think a lot of construction, I mean, whether they're clients or construction companies, etc., may not be really interested in maintaining this data, but because obviously it's not enough to collect this data at the construction of the building. you have to then update it as data as the building gets maintained, etc. What is the current status, etc. So, but this data, of course, will become very valuable towards the end. So the idea could be that whoever owns the data sells it, and obviously initially is going to make very little money on it, but at least they're gaining some funds. The person who sells it sees it as an investment in the long term, and whether actually the value of it will rise over time. And this is kind of the idea of the stock market. So we give it to others to actually make this happen.
Very interesting. So there is a question for Peter from Wendy. Sorry about the pronunciation. Wuyutz. Sorry. A question for Peter, because you address the system beyond the buildings. Space is perhaps the most needed resource in many growth-oriented cities. At least I think you're right. Where there is also agendas of the need for more housing and urban greening. Having space for temporary storage of materials or even for conducting the urban harvesting activities might be not so feasible. I also agree that configuration is important for recovery, but how do you integrate space in determining the recovery yield, especially in cities where there are tensions between different agendas? Comment on that, Peter?
Yeah, thank you for the question. I do think I need to ask a clarification or unpack it a little bit in terms of when we were talking about urban harvesting between quotations. It's about the idea that you know what materials you get back. It's not a kind of urban farming approach or something like that. So in that sense, you just know what you get back from the buildings, or you know it more precisely. That is the paradigm. So in that sense, spatially, of course, yes, reusing materials versus components versus modules all has different space needs. But that's not really the model talks about understanding it better, and maybe you see that, oh yes, okay, this approach takes too much space in a city like Singapore that doesn't have a lot of space or something like that. So maybe by understanding those different goals or approaches, you can then pinpoint which ones are more interesting in which case. Because I agree that space is always at a premium, and I think all cities have tensions between different agendas. That's the nature of cities. But so spatially, what we're suggesting is not different, other than if you do have, need to stock the materials, but that it'll be the case in any circular economy approach, whether you're stocking materials or components or modules, or whether you're keeping it in the building. Maybe if you don't have space, well, then you need to use a strategy that focuses maximally on reusing the entire building or most of it, because you don't have the space to store the materials. But maybe you can open up a market internationally, and then of course you need building information that can travel between nations, and you need a data provider that actually can warrant information quality between countries, and so that's how the whole thing starts rolling. But so yeah, I think that answers the question, I hope.
Okay, thanks. So, and if it doesn't, when do you have to contact?
Yes, you can
afterwards. Yeah.
Afterwards, or give me an email. Send me an email.
Exactly. And that's the whole idea with the webinars. There is some follow-up work, homework after the webinar, which is more important than actually asking a question in the discussion here. We have only a couple, let's say 1 minute to go before we need to give the word back to the organizer. And Verena, you also posted a message. You said, I found very interesting what Professor Stoff said. We need to adapt the needs to what is available in terms of materials. But how can we steer or manage these needs and accurately project these future needs? So I guess that goes about knowing where to focus before you have the knowledge, because you didn't build the models. So at the early stage, anticipate where you should focus. What do you think? Any final comment, but not too long, please, Rudy, on that?
Yeah, I don't think I can answer this entirely, but I think that you know, such initiatives like LEAD, etc., would just have to be expanded to incorporate this. This is an incentive for people to, you know, make more use of existing materials, and it could become a little bit of a competition. I think, you know, the different stakeholders, different partners, different directions have to play a role in this. I don't think there's a single answer for this.
Yeah, no, I agree. It's difficult to answer that. Anyway, I guess time is out for the discussion. So thanks a lot for your contributions, for the questions, and for your answers. I think there is very much interesting stuff behind what you presented. So at least I would really love to go more in detail into the presentations that you have shown today. So please make that available as soon as possible. Thank you very much, Verena, and then I give the word back to you.
Yes, thank you also from my side to everyone. The idea was to give the word to Antonio Lorena to close the session, since he's the one organizing the Circular EcoBIM project. So let's give him the word.
Thank you, Verena. You could have closed the session also. But just a few words. It's up to me to close the session as one of the co-organizers of today's seminar. Just these few words just to thank everyone, especially the authors that gave their insights and ideas, shared their ideas with the rest of us. I think most of us have probably seen a significant overlap, which is always good. It confirms that we are looking at the same problems. Hopefully we will come to different solutions that complement each other. So hopefully that's the spirit of this research community, the ISIE community. And of course, we also have to thank ISIE for the opportunity of hosting this session, and which had a very significant turnout. So kudos for everyone for participating in this session. Thank you so much, and hope to see you soon.
So Verena, would you like us to stay?
You want to stay and discuss more? Feel free to stay.
We're just looking at who's not leaving the session.
Those who are out for a cup of coffee.
Exactly.
It was a very nice session.
Yes.
It was.
Very nice.
Yeah, the team from ETH Singapore has clearly a lot of these same challenges mapped out.
Yeah,
so it's good.
Very well organized.
Yeah. Okay.
Have a good day. I'm going to close.
Bye-bye, everyone.
See you.
Thank you. Have a good day.
Bye.
Have a nice
Bye-bye,
day.
everyone.
Bye-bye.